Okay, this is Unit 2, Lesson 4. The warm-up is just going to be going over what we did last day in Unit 3. Today we're going to look at polygons, and we're going to look at interior and exterior angles. And I want you to think about polygons as things that are built from triangles. And if you think about it like that, it'll make it easier in terms of trying to figure out the total number of angles that are found inside of each shape, and the total amount that, if you added up all the angles, what it would equal. So for the first one, for a triangle, we know there's 3 sides, and there's just one triangle. And the sum of all the angles we know is 180. If we look at a quadrilateral, if I split it in half, like that, each triangle is going to be 180 degrees. So we know that the sum of all the angle measures is going to be 360 degrees. There's 2 triangles, and there's 4 sides. For a pentagon, there's 3 triangles. If you split it like that, each one's going to be 180, and you can see that there's a pattern starting to being formed here. A pentagon's 5 sides, there's 3 triangles, and there's 3 times 180, or 540 degrees. For a hexagon, I could split it, well, it's going to be a little bit harder. I can split it like this, and I have 1, 2, 3, 4 triangles. 4 times 180 is 720. And for a hexagon, there's 6 sides. Okay, getting onto this one, you're getting the idea in terms of the pattern starting to form here. This one we can split 2, 3, and 4, so we get 5 triangles total. 5 times 180 is 900, and there are 7. And on the last one you get the idea, I split it all up. There's 6 triangles that form, and 6 times 180 is 1080. Now there's got to be a faster way of doing this, because you might be dealing with a polygon that has 15 sides, and you really want to be figuring out drawing all these triangles. No, there's got to be a faster way. And we'll take a look at how to do that. Okay, so what is the relationship? What is the relationship, and how could we express it using a formula? And that's what I'm going to show you right now. So the formula we're going to learn, which we're going to take a look at of how it came to be, is simply S equals 180 degrees and then n minus 2. And n refers to the number of sides in the polygon. Okay, good so far? Okay, so what we're looking at is this relationship works if we're talking about convex polygons. Convex polygons are polygons that look like this. So this is a convex. This is not. This is something called a concave polygon. So it works for this one, does not work for that one. And the reason is a concave polygon has an angle inside of it that's greater than 180 degrees. This does not. All the angles inside, the interior angles, are less than 180 degrees. So it only works if we're talking about these ones, and these are the ones that we're going to work with. Okay, so to put it into words, a convex polygon is just really a polygon in which each interior angle is less than 180 degrees. Okay, and a concave is simply a poly in which one or more interior angles are greater than 180. Okay, now the next part is always the fun part, and that's proofs. This is a pretty complex shape I'm going to be drawing here, and I'm going to kind of try to do this as best as I can. And the way it's going to work is I'm just going to put points and then connect the points because it's easier to draw that way. So my drawing is probably not going to be the best because you know how good I can draw. So my drawing may be pretty crappy, but we'll try our best. Okay, so I'm going to just connect this polygon like that. And you should do the same. And then if I thought about this and I listed how many sides there were, 1, 2, 3, 4, 5, 6, 7, 8, 9, we could continue to make this polygon bigger and bigger and bigger and bigger, and I mean, we would be there forever. Now, the thing that you want to think about is that for every side, you could extend it with a triangle coming into the middle. And what do I mean by that is I'm going to put an imaginary center in the middle. It doesn't exist. There's nothing there. I'm just going to draw it, and then I'm going to lightly draw in triangles. So if you thought about it, if I wanted to know all the interior angles, in other words, all these angles that form here, so I want to know this angle, this angle, this angle, that angle, that one, that one, that one, and that one, and that one, but not this middle angle, because really there's no triangles in here. We just drew these triangles in. So if we think about it, we know that each section is going to be worth 180. So if I went 180 times n, or 180n, that would add up all the angles. So it would add up that angle and that angle, all of the angles around. But it would also add up these middle angles, which we don't want because we don't really have those triangles there. So we have to get rid of them. So if we think about it, if I went all the way around and I added up just these inside angles that really are not there because there's really not these triangles there, that adds up to 360. So really, if I went 180n minus 360, that would remove these middle angles and that would just add up the outer angles, which is really what's found in this polygon. So hopefully you understood that. If you didn't, pause the video, go back and watch that part again because it's really important. So if I simplify this and I factor out 180 out of this, I get n minus 2. And if we think about it, that formula I gave you earlier was 180 degrees n minus 2. And that's why this formula came to be, is that we're really removing the middle angles because we're kind of drawing triangles to count up the angles, and we don't want these middle angles here because they don't exist. There's no triangles being drawn there. So that proves why this holds true for convex polygons. Okay, I'm going to pause the video there, and you can watch part 2 after this. If you didn't understand the last proof, go back and watch it again because it's important.